In a giant industrial hangar on the eastern coast of Scotland, technicians are servicing 2 turbines, each with 3 30-foot blades. They're not wind turbines. These are actually designed to be 100 feet underwater, capturing energy not from the wind, but from tidal currents. Once they get this 150-ton turbine into the water, this entire thing will swivel with the tide 4 times a day, generating about enough power for 1,000 homes. For the past year, these turbines and 2 others have been in the Pentland Firth, a strait off the northern coast of mainland Scotland. It's called the MeyGen project.
The blades, for example, we make from carbon fibre. So
Eddie Scott is the health and safety manager with Simec Atlantis Energy and part of the team that oversees installing these devices underwater. To get them in place, the turbines are guided onto steel bases on the sea floor. You can drop this in onto its base and get it plugged in how long?
We can do that within about 30 to 40 minutes.
As the tide ebbs and flows, the turbines spin between 7 and 15 times a minute, generating power, similar to a wind turbine. Cables carry the energy back to the shore, first underwater, then underground, where it's then fed into the national grid. The tides are so predictable that Atlantis says it can tell how much energy these turbines will generate every 15 minutes for the next 25 years. So you don't have to worry about whether there's clouds on a sunny day for solar. You don't have to worry about whether there's a stiff breeze
That's the real advantage of tidal energy. It's very, very predictable.
Scotland is estimated to have 1/4 of all the tidal energy resources in Europe, and Scottish companies have helped lead the way in developing technology to harness those currents. MeyGen, here in northern Scotland, is the world's largest planned tidal project, and over the next 4 years, Simec Atlantis is planning on installing more than 250 additional turbines.
When it's fully done, you're talking more than 250,000 homes can benefit from the power that's generated from this array of turbines.
Tim Cornelius is the CEO of Simec Atlantis Energy. The company says the turbines at the MeyGen site are expected to last 25 years and only need to come out of the water for maintenance every 6 years.
It's in a very, very stable environment. And more importantly, from a permitting and consenting perspective, you don't see them and you don't hear them. And that's very, very important for local communities.
But it's expensive being first. The cost of producing tidal energy is more than 2.5 times the more established technology of offshore wind. The MeyGen project has cost about $64 million so far and has been largely subsidized with public money. Almost half of the total cost has come from the Scottish government.
We are very, very grateful for the support that we have received over the past 10 years from the UK government and in specific reference to Scottish government support because it's been outstanding. But of course the aspiration is to eventually wean itself off subsidy.
As the project continues to expand, Cornelius says costs are coming down. A year after the turbines were installed, the price Simec Atlantis charges the utility company for its tidal power has decreased by 50%.
The Scottish Government has provided consistent and long-term support for these technologies.
On stage, Paul Wheelhouse. He's the Scottish Minister for Energy, Connectivity and the Islands. We sat down with him at a conference on ocean energy in Edinburgh. Can this industry survive without government subsidy?
We believe key technologies are already close to being in a position where they can survive without subsidy. Other technologies which are newer, emerging technologies, do need, we believe, continued support to get them to commercial scale, to get them utility scale projects that will then get the economies of scale in the manufacturing process and drive down the price, improve their competitiveness.
Wheelhouse says these government investments will help Scotland reach its goal of being 100% powered by renewables by 2020. And then there's the transfer of technology that's happening.
The great secret about the tidal power industry is while it looks like an incredible leap forward in engineering, actually all we've been doing is just stealing the great ideas of the oil and gas industry for the last decade.
The facility where the tidal turbines are maintained also supports oil and gas platforms.
Big cranes, heavy lifting equipment, moving large portions and large chunks of steel around. Some of the subsea technology is very, very similar. So there's a tremendous amount of existing technology that we're using and capitalising on.
For Wheelhouse, relying on the technology and knowledge gathered from decades of oil and gas exploration means continued jobs in this new energy sector.
We don't want to leave communities, entire communities behind, as has happened in the past with coal mining just abandon them and leave them to their own devices.
So you're saying that you are creating opportunities for, whether it's coal miners or oil and gas workers, to transition to this new renewable economy. And with a growing threat of climate change, Wheelhouse says the time to invest in new forms of renewable energy is now.
We have long argued that there is an economic advantage in moving early, not least because we will have to do this. I believe firmly that climate change is happening and we cannot avoid tackling this issue globally.
While the tides these turbines are gathering energy from are predictable, the political winds around them are not. How Brexit could hamper this emerging industry. That's the subject of our piece tomorrow night. On a brisk November morning, I headed into the waters around the Orkney Islands, an archipelago off the coast of northern Scotland. I'm with a team from the European Marine Energy Centre, or EMAC, a research and testing facility that's based here. I'm also with a Spanish renewable energy company that's testing its new project here in Orkney. This device generates power from the tides.
We have already produced energy with these platforms.
Pablo Mencia is a project manager with MeyGen Renovables, the company that developed this device. He took me aboard to get a closer look. Why come here?
We are coming here because this is the most important place to test this energy.
The floating deck is about 150 feet long, and when it's in place, it'll be tethered to the seafloor with chains. The tides rush through two giant underwater turbines beneath the deck and generate energy. The device was towed more than 1,300 miles from Spain, and soon will be connected to the grid at EMAC's test site in Orkney for a year.
We want to validate this technology, to optimize our platform and try to reach to the commercial point and start selling platforms.
Mencia took me inside, where electrical converters transform the power generated from the tides to a standard voltage before sending it to the power grid onshore. When it's operating, there won't be anyone on board. It can all be monitored and controlled remotely from anywhere.
This is our control system. We can check everything from Spain.
So 24/7, this is all sending in information in real time?
Yes.
EMAC has tested more than 30 ocean energy devices, including this one, which recently generated enough energy for about 830 homes in a year-long test. Manufactured by a Scottish tidal energy developer, it looks like it's moving, but really it's just the tides rushing by. Like the MeyGen device, it's tethered to stay in place, while turbines underneath gather energy from the moving water. Lisa MACKENZIE is EMAC's marketing manager. She says that in addition to having a testing site for devices that create power from tides, EMAC also has a site to test wave energy.
Orkney is very, very unique because it has both of those resources very close together.
Here at Billy Acrew, waves have been measured at nearly 60 feet high. More than a mile offshore, a Finnish company is testing a device that captures energy from the movement of these waves. It then feeds that energy via underwater cable back into the national grid.
It's really important to do the computer modelling and to do the tank testing and get a lot of the issues ironed out as much as possible at scale, but you cannot understand how a technology is going to interact in the real sea environment at full scale until it has been deployed.
EMAC, which is a non-profit, was established in 2003 and has received about $44 million in public funding, including from the European Union and the UK and Scottish governments. It's been self-sufficient since 2011, with companies paying to use its facilities. But it still does receive EU grant-funded projects. In fact, the cost of MeyGen's year-long test at EMAC is being subsidized by EU funding. So while tides and waves here may be strong and certain, the political winds are anything but. The United Kingdom's Brexit is set for March, after which Scotland will no longer be part of the EU, and the fate of EU-funded projects in Britain is uncertain. You're a European-funded agency in the first place. What happens next year?
So we're called the European Marine Energy Centre, but we see ourselves as very much a global company, and whatever happens with Brexit, and at the moment we don't know what that will be, that's not going to stop us working with European and global companies.
Paul Wheelhouse is the Scottish Minister for Energy, Connectivity and the Islands, and a member of the ruling Scottish National Party, which did not support Brexit.
We are, regardless of perhaps some of the Brexiteers' views on this, we will always be part of the European continent. Geography doesn't change, And we have a huge share of Europe's wave energy, tidal energy, and offshore wind and onshore wind potential.
We spoke with Wheelhouse at a recent conference on ocean energy in Edinburgh. As Brexit approaches, he warns the UK should not repeat the mistake that it made in the 1980s with wind energy.
The industry was being led by academia in Scotland and the rest of the UK, and indeed I think some of the first onshore turbines in the world were trialled in Orkney. And then we dropped the ball because there was a dash for gas, and it was more politically expedient to push for a short-term hit and an agenda, and neglected the long-term development of a technology that had huge potential.
Today, the wind energy industry is dominated by Danish, Chinese, German, and Spanish companies.
So we're saying to the UK government, please, desperately, do not drop the ball again.
And EMAC in Orkney is not the only investment the Scottish and UK governments have made in developing the ecosystem around marine energy. David Ingram is an engineering professor at the University of Edinburgh and the director of the Flowwave Ocean Energy Research Facility. This 634,000-gallon tank was funded in part by the UK government and opened in 2014. It's a place where you can rent a stormy sea, pick the size of the wave or force of the tide, and test whatever you like.
So if I want to have a 200-year storm, I can have 200-year storm conditions every 15 minutes. If I go to the ocean and I want a 200-year storm, I might have to wait 300 years for that 200-year storm to come along.
On the day we visited, this small-scale version of a wave power device was being put through the equivalent of massive swells by a Swedish company.
It's much cheaper for you to bring a model here from Australia and test it, or from Sweden and test it, than it is to replicate this facility.
Ingram says research like this around emerging technology is only possible with government assistance.
You get to the point where there needs to be national support for something to happen at a large scale, and if the government don't want to provide that support, then that technology goes to somewhere where the support can be found.
Adding to the uncertainty around Brexit, Scotland is not the only government racing to develop these new technologies. Representatives from all over Europe were at the Marine Energy Conference in Edinburgh, and the United States was represented as well. Tim Ramsey is the program manager for the U.S. Department of Energy's Marine and Hydrokinetic program.
We're learning as much as we can from our counterparts over here in the UK.
Ramsey's office distributes about $70 million a year in grants for marine energy. With U.S. Department of Energy support, Tidal devices have already been tested in Maine and New York. The Department of Energy is also helping build a $50 million wave testing site on the coast of Oregon. Modeled on facilities like EMAC, it'll be able to test utility-scale devices. Ramsey thinks American companies still have a chance to catch up to the Europeans.
We're not as far along as them, but they're not that far out in front of us. We can still catch them, and we can still be the world leaders in this space. When you look across the country and the resources that we do have, it spans them all. We have a great tidal resource, a great wave resource. We have the supply chain. I think we'd be missing out on a big opportunity if we don't take advantage of that.
But despite the investment, there are still questions as to whether or not developing technologies like tidal energy can compete with existing fossil fuels and more established renewable energy technologies like wind and solar. Tim Cornelius is the CEO of Simec Atlantis Energy, which is developing the MeyGen project, the largest planned tidal array in the world in northern Scotland.
Tidal power is where wind and solar was 15 years ago. The world's best resources, closest to distribution points, are yet to be developed.
Cornelius hopes that projects like MeyGen will prove that commercial-scale tidal energy is feasible. As the sun sets and the moon pulls these tides to rush by at 11 miles per hour, spinning underwater turbines are helping keep the lights on.